Hello folks, another quick kind of an update video. So a little bit that's been going on here. Well, it's actually pretty clean here at the moment, which is great. I've been having an assistant now a few times actually, and she's doing a great job cleaning and also doing some other jobs as well. And we got done a bunch of these. I think it's 94 pieces of these little steel pieces with a slot milled. It's a 10mm slot, a little under ½ inch. It's 130mm long and 25 by 25, so about 5 by 1 by 1 inch. There's two more which are undersized for some reason. I'll use them for something else. And here I've got some pieces of aluminum which will go to the milling machine next. So I've got two more of these to do. The stock is right here. And I have two finished pieces right here. These make a little mountains of chips. So after I've finished the last two pieces, I'm gonna have to do some serious cleaning. One of the very few things that I don't like about this machine is that it doesn't have any kind of chip removal device, chip conveyor or anything like that, like my lathe has. So you just have to manually get rid of the chips, and it's pretty time consuming actually. The pieces come out pretty nicely. And of course this is just operation number 1. There's 2 more operations. So the next one will be to flip it and do the same thing to the other side. And then there's gonna be some through holes as well. That's gonna be operation number 3. And got some different sizes of aluminum chunks. And I've also got some other stock that I will cut to pieces myself. But this stock is so large that I don't want to use my saw to cut this because it's gonna take forever. So I think let me pull out these pieces and maybe I can show you the making of the last two. So, how I set up my pieces. First I find a corner that's not dented, and so that it will sit nicely on the vise. And this is the edge that I'm gonna, or the corner that I'm gonna choose to sit against the X-axis top. So it's gonna go here and against the stop. Then I'm gonna tighten the vise with moderate pressure and removing the parallels. Only got one set of these parallels. I wish I had more. And same for the other one. If I wanted to take advantage of these parallels, I would of course leave them in place and use a soft hammer to tap on the piece so that it would sit against the parallels, but it doesn't matter at the moment. When I'm doing operation number 2 and 3, then I need to leave the parallels in place and tap the piece so that it's gonna sit straight. But now that the whole piece is still rough in all sides, it's just fine to leave it like this. Okay, let me clear some chips and then we should be ready to go. Okay, the material is in place and most chips have been cleared off. So I'll shut the door and type in DNCX and press enter. So now it's ready for data transfer from the PC. And usually when I do more than 3 of the same part, I always send the program to the machine so that I don't have to come here to the computer. But this program is so large that I have to drip feed it, meaning that this PC program sends the CNC program line by line. So you can basically do any type of a huge program on a very old machine if you like to, in this way. But it takes a tiny bit longer to come here and press the 2 buttons. So now we come back to the control and press start. And let's see what happens. First it's facing. It's taken off only 1 millimeter or 40 thousandths of an inch. Switching off the coolant for you. In future I'm planning to buy some more vices. I think 4 vices would be pretty optimal. But so far I haven't gotten to do very large batches of parts. So, and this is the most number of parts in this batch is 24 a piece. So it's pretty easily done with just 2 vices. And this is a 20mm carbide drill. And this is some very aggressive drilling. Very aggressive. It actually even shows in the load meter quite a bit. It almost tops it up. But that's pretty quick 20mm holes. And the drill is actually a little bit worn already, but it's still doing okay. And this is also pretty interesting stuff. Switch off the coolant for you. This is also showing in the spin load meter. This is pretty much maxing the tool. So it's a 10mm solid carbide end mill, meant especially for aluminum. It's very sharp. And the width of cut is 1mm or 40 thousandths. And the feedback tooth is 15 hundredths of a millimeter or 6 thou per inch. 0.006 of an inch per tooth. And the cutting speed is like 240 meters per minute. The maximum that this machine can do with the 7,500 RPM. Making lots of chips. You can see some smoke rising from the coolant vaporizing. Now finishing with a very slow feed. By the way, the feed rate was 3000 millimeters per minute. So it's like it's like 100 feet per minute, or 100 if it is. No, of course it can't be. So I guess it's too late for me to do any calculations. It's been a long day. So do the calculation yourself. And now for the second piece. The chips are actually a little bit more manageable when not using coolant, because they tend to pile up on top of the vices when I have the coolant on. But of course when finishing, the coolant is a must for surface finish. Okay, and by the way, the block is now done. I was too busy to make any video of it, which is kind of sad because this is the first project that I was using the Coromil 745 right here. Maybe you can remember this from, I think I actually bought this last summer. It was a brand new Sandvik Coromant product. I will make a video of it for you someday. At least for cast iron it did really well. It's made a beautiful surface finish. And here are the pistons that I lowered. And what else? Well, I installed a proper light for the CNC lathe. Works pretty well. I also have quite a bit of work for the lathe, but at the moment I'm just too busy to do it. So, well, I guess some more future news is that we are getting married with my girlfriend finally in 2 weeks. And after that we're going to travel in Europe for about 3 weeks. So it's gonna be pretty much a full month of vacation, which is pretty awesome. I haven't had a month's worth of vacation in years. So we're both very thrilled about that. So when we get back from the holiday trip, I'm gonna do some lathe work as well. And now you can actually see this small lathe cleaned up. The cleaner lady does a pretty good job. And what else we have? Well, here's some more stock for the parts that I'm doing now, for the batch of parts. And here I got sorted out some CNC lathe tooling. So this is a Morse 4 holder. And these are kind of well-done holders. So these sit in the in the boring bar holders. So you can actually have just ordinary drill chucks in the CNC lathe. And here I've got some pretty good chips on the floor again. I did some good amount of aluminum work. 95% of the chips are in the chip bin of the lathe. They're gonna get cleaned soon. I don't wanna go there because I don't wanna get the chips on my shoes. Let's go back to see what's happening at the milling machine. I think this is also pretty interesting. So this is a really nice roughing tool for aluminum. It's a 3-flute solid carbide with variable flute geometry. Cuts really nice. And now 10mm ball and mill for finishing. Okay, from now on every operation has to use coolant, so not much more to show you. Okay, I think this is all for today. It's almost midnight actually, and I'm really gonna go to sleep after these 2 pieces. So, thanks for watching and until the next video.